like your haircut, by the way.
Thank you.
It's so short and so tight. I love it. I want short hair too. Can I go?
Yeah, it's fine.
Okay.
I'll go back.
What?
I don't know. I wanted to grab my calculator.
Calculator?
Yeah, I'm trying to figure out this notes while I do your recording.
Okay. You can sit on there, it's fine. Does it need to move down?
A little bit, but it's okay. Don't worry about it.
Alright. Okay, now we're going to talk about polar coordinates. So the first lesson we're going to do today is on basic polar coordinates. So polar coordinates have two parts, just like rectangular have x and y. You have r and theta. So in this graph right here, I have two lines, and you can see theta is the angle and r is the distance from the origin. So if this is the origin, r is the distance, and that's defined as r comma theta. So it's important to know how to convert from rectangular, so that's your xy coordinates, to polar, and from polar back to rectangular. So these four formulas are what you need to know. So if you're given rectangular coordinates, you can use your y and x points to find theta and r, so that will be finding your angle and your distance. If you're given polar coordinates, you can solve for x and y using r cosine theta and r sine theta. And the reason why is because if you drew out this graph and defined all your points, this value here is your x value and this is your y. So tan theta is y over x, and then r squared is x squared plus y squared. That's like the Pythagorean theorem. So that's where those formulas come from. You have your example 1 is up here, and that says to convert to rectangular, and you're given 4 comma pi over 6. So you're given polar coordinates. The way you want to do it is you want to use these two formulas. You want to solve for x and y. So you get x equals 4 cosine pi over 6, which simplifies to 2 root 3, and y equals 4 sine pi over 6, which simplifies to y equals 2. So your final rectangular point will be 2 root 3 comma 2. If you're converting back to polar, like in example 2, you can see I've given you negative 1 comma 1. So you want to use r squared equals x squared plus y squared, and tan theta equals y over x. So if you're solving for r, you put in x and y, and you get r equals root 2. And if you're solving for tan of theta, you get negative 1. And if you found tan of negative 1, that will come out to 3 pi over 4. So your polar coordinate that would look like this is root 2 comma 3 pi over 4. The last thing we're going to talk about is derivatives of polar curves. We'll get to polar curves in a later video, but all you need to know is that if you can find r and theta, just like you find dy dx, you can find dr d theta. So dr is the change in radius, and d theta is your change in angle. So when dr d theta is positive, that means your point is moving away from the origin, or your change is positive, so all of your values are increasing. If your dr d theta is negative, then your point is moving towards the origin, so all of your values are decreasing. Paused. Okay.